Well, and really this is a bit misleading. There are lots of different radicals, but we're just going to focus on square roots.
Yes.
Square roots. I think we talked about some of those other radicals before. So I got a ton of examples. We're actually going to spend 2 days on 9.1, 2 days, because there's a lot of stuff. There's a lot of stuff. But first things first, let's kind of review some of the more straightforward examples. You're going to be asked to do a lot of simplifying in this section. And let's start off with square root of 4. It's 2, isn't it? Now, there's a couple ways to get that answer. One way to get that answer is this actually asks a question. It says this has an index of 2. We just don't write it. But this says what number multiplied by itself gets you 4? And the answer is 2. Now, some other ways to go about that is you can memorize perfect squares. 4 happens to be one of those perfect squares. What are some other perfect squares?
9,
61, 64,
25, 64,
101,
49, 1, 81, 121, yeah.
25 is
What's that?
12.
121.
25.
85, yeah. All right.
I know.
Well,
What the heck?
But ladies and gentlemen, here's the thing. If you know perfect squares, you're going to get this one super quick, right? If you don't know perfect squares, I still want you to be able to figure this out. So an approach that I like to use if I don't know how it simplifies is I just break it down into factors. What times what gets you 4? And it turns out, because it had an index of 2, any pair of numbers is a perfect square. Will come out. So if you get to circle a pair, that one comes out and you're done. You're done. So we'll explore that idea more here in a second. So what about square root? I didn't hear this one. 36. Is that a perfect square? Yeah, it's 6. But if you didn't realize that, you might say, oh, 36 is 2 times 18.
No, you won't.
I mean, it is. But what is 18?
6.
3 times 6. Do I have any pairs yet?
No.
But what's
2
6?
times 3.
Now take a look. Don't you have a pair of 2s?
Yeah.
And a pair of 3s?
Oh, so you multiply by 3 times 6.
Exactly. The 2 comes out, the 3 comes out, and guess what they always do?
Multiply.
Yeah, they multiply. Now again, is it way quicker to have your perfect squares memorized?
Yeah.
And also, doesn't your calculator have them kind of memorized? So couldn't you punch in square root 36 real quick? Yeah, and just see if it comes
Wait, I
out.
have a question.
Yeah.
So is there like a rule to help you remember perfect squares? Or you just got
Not really.
My
Yeah.
brain does not have enough.
If the same
That's
number
all right.
is times by itself. that's
Yeah.
perfect.
So what you do, Adelaide, is you can make a list of them to like study. Just to start, go, what's 1 squared? 1. What's 2 squared? 4. What's 3 squared? 9. 1, 4, and 9, those are all perfect squares. So you can make a pretty quick list on a sheet of paper and just stare at them a little bit. Yeah. Yep. All right. And what about this one? Square root of 81.
Oh, 9.
It's 9, isn't it?
I knew.
But if you don't know that, you can do a factor tree, can't you? And I don't care if you do it or not. Wouldn't most people do 9 and 9?
Yeah.
Well, you can actually stop right there. Don't you have a pair?
Yeah.
Yeah. But if you didn't realize that, guess what you might do? You might break this thing.
Then, because you have 4 of them, you multiply them, then you have 9.
So,
Yeah,
So-
we should say like some people not.
a 3 comes out, and what would they do? multiply together to make a 9.
I'll be smarter.
Okay, well, so these are all perfect squares. You could get the answer right away. But if they don't have a perfect square, like square root of 147, see if that's a perfect square.
It's not.
It's not, because you get decimals, right? So if that happens, you have no choice but to try to break it down. Now what a lot of people do is they try to think of the biggest perfect square that will divide into this.
144.
Well, 12 times 12.
Plus 3.
Well, 12 is not a perfect square. 144 is.
49.
Yeah, but does 144 divide into 147 nicely? No, we got to think about dividing into it nicely. So here's the thing. I don't have a lot. I'm not super good at dividing by bigger numbers. So I'm just going to do this as basic as I can. Does 9 go into this?
No.
Okay, no? Well, shoot. Let's just try 3. Does 3 go into it?
Yeah.
3 does. 3 and what?
Big number.
49.
Oh, dang, look at that. 49 is a perfect square. So the answer is going to be 7, because what's the square root of 49?
7.
And then what's left over?
3.
A 3. Now, here's the thing. If you didn't catch that this was a perfect square, you're going to break it down again. And what goes into 49?
7.
7 and 7. And are you still going to get a 7 coming out and a 3 left over? So how you know you're done with these problems is what's left over in here should not have a perfect square in it. Should not have a perfect square in it. Yeah, so if like somebody said, hey, I'm done, you would know better, wouldn't you? You'd be like, no, you're not done, because what's the square root of 49? 7, and it'd actually be 3 times 7, or 21.
So whenever,
Question size?
whenever you have stuff left over, you're supposed to like square it.
Say what now?
Whenever you have stuff left over, you're supposed to like square root it.
Well, yeah, if you got stuff left over, you haven't evaluated the square root of it yet, so you keep it under the square root symbol.
Oh.
Yeah. What's up, Adelia?
So do you just like leave it like that, like 3?
That's the answer.
7 square root 3. Well, because 3 wasn't a perfect square, we weren't able to simplify it.
Okay.
So it stays.
But
It stays.
how does that equal 147?
Well, in your calculator, punch in square root 147, and you're going to get a messy decimal.
Yeah.
What's that messy decimal rounded to 1 decimal place? 12.12?
Yeah.
Okay. Now do 7 square root 3 in your calculator.
I can do that.
147.
9.89.
You did 7 times square root 3?
Oh.
Do 7 times square root 3.
I didn't do that.
12.12.
Same thing. It's the same thing. Yeah. So these are equivalent, but this is the simplified version. This is simplified. Now, here's the deal, ladies and gentlemen. You can also round this answer, but is a rounded answer exact? It's not. Okay. All right, let's try another one like this. Square root of 108. It's probably a good idea to check real quick. I don't think it's a perfect square root. Well, what goes into 108?
12 and 9.
Oh, 12 and 9? That's interesting. Yeah, we can do 12 and 9.
And 9 is 3.
Oh, 9's a perfect square, isn't it?
So would it be 3 square root 4? Or
Well,
what is
it'd
3
be
times 4?
12,
6 times 2.
Well, doesn't, let's just break down 12. What goes into 12?
3 and 4, 6 and 2.
3 and 4. Now, you could stop right here. Because what's the square root of 9? 3. What's the square root of 4?
2.
When they come out, they always multiply. When they're left over, they always multiply. So what's left over though?
3.
Three,
So we go square root 3.
so 6.
And just to be clear, this right here, it's always multiplying when you write them side by side. So one way to do this is to get 6 square root 3 that way, looking for perfect squares. Now notice, we might have instead, what's 4 times 9? What's 4 times 9?
36.
Guess what? If somebody was really clever, they would have done 36 and 3. Now why is that clever?
Guess 36.
Because 36 is the biggest perfect square that goes into 108. I'm not good at picking the biggest perfect squares, but I'm perfectly happy just breaking them down and looking for pairs, looking for smaller perfect squares. You
So
got,
do
yeah.
we square root like all the pairs? Like you square root 3, 4. Do you always do that? Once you get
Yeah, if you have multiple perfect squares, they all get square rooted and come out.
3 times 4. So you
Mhm.
square root that.
Yep. Yeah, Jazz.
Okay, so you don't have to go to like, you can't like split it anymore. So, like,
Yes.
So like the 12, you can't just stop there.
Can't just stop there because it has a perfect square hiding. Yeah, exactly, exactly. Now, ladies and gentlemen, does everybody agree that if you don't realize you have perfect squares, you would end up having to like, wait, no, that was 4 times 9, wasn't it? You'd end up having to just break it on down and then look for pairs. But do you see how you still end up at the same spot? Yeah. Still end up at the same spot? Still have that. Some people, when they first start doing these, they start saying, well, why didn't I write down the 9? Well, it's because the 9 broke down. You're not looking at these numbers. You're looking at the ends of the branches, right? The ends of the branches. Okay, let's try another. Well, actually, let's write us a little sentence down because we haven't done much explaining. So let's do some explaining. A square root radical is in simplest form when no perfect square squares are factors of the radicand. Yeah, we're using a little bit of vocab there. Oh, and sorry. There you go, internet. Well, so a square root radical is in simplest form when no perfect squares are factors of the radicand. Now they're using some vocab there. This is a radical. As soon as you've got that square root symbol, it's a radical. It's in simplest form when there's no perfect squares in the radicand. 147 is the radicand. It's the number inside. So a little bit of vocabulary is like on this one, the index is 2, the radicand is 147.
Do we need to know the
And
index?
do what?
We need to know that's called the index.
No, you don't really. I don't think that's going to be extremely important. Because they're all going to be square roots. They're all going to be the same index. But so, Jazzy, that right there is why 12 wouldn't be done. Because 12 had a 4 inside it. Yep. A perfect square as a factor. What do you guys think? Okay, let's get a little bit weirder before we go to lunch. Wait, when is lunch? Oh my gosh, we got tons of time, don't we? Tons of time. Okay, let's get a little bit weird and let's do square root. Oh, by the way, the instructions are still simplified. You guys with me? Emma, you should probably just holster that thing. Just put it away. Yeah, that way you're not tempted by the dark side. Alright, 9x to the third. So now we got a variable in there. What? 9x to the third. Well, that wouldn't be completely simplified. You'd be getting there though. You'd be getting there. Well, so it sounds like you guys totally confident in this being a perfect square.
Yeah.
But 3's not.
But 3 is an exponent, isn't it? Let's think about this for a second. You know how if we had a pair of factors, we could take it out, it was a perfect square? Can't you rewrite x to the third as x times x times x? We have a pair of x's. So what's going to come out?
X squared.
3 squared.
X squared.
What's the square root of 9?
3.
What's the square root of x times x? Just an x.
Oh.
Just an x.
Oh.
Remember,
Like
for
1 times 1.
yeah, just for a pair of them, only one comes out. So just an x. And now, is there anything left over?
There's one.
The X.
There is an x left over.
Wow.
That's easier than I thought.
Yeah.
My brain's
Yeah.
So the leftovers on the x side.
Now, here's what's scary though, is what if instead of being x to the third, it was x to the 53rd?
Oh, no.
Would you list all those out?
No.
Circle them?
If I
No.
had to.
But, can I show you, can I show you a shortcut?
Yes.
What you can do is, it turns out if it's odd, this isn't a perfect square. But if you rewrite it as an even exponent, it turns out that's a perfect square. And I'll show you why here in a second. Now, is x to the 52 the same as x to the 53rd power? Because I need to multiply it by what?
An x.
An x. Because do you agree that now they would add up to 53? So it turns out if this was the problem, this is kind of weird, but square roots, they actually cut exponents in half.
Interesting.
So the answer to this would be 20, whoops, that's not a 20. It would be 26 square root x. Whenever you have an even exponent, you just cut them in half. Cut them in half. So it's a shortcut that you can use. So on our first example, didn't we have, it was x to the third, right? You could write it as x squared and x, right?
Oh.
But this is a perfect square. Cut that in half. What are you left with?
1.
Yep, so it'd just be x and then a square root of x left over.
Screwed.
Kind of weird, huh? Kind of weird. Well, let's do another, shall we? Negative square root 25x to the 5th. What do you suppose that negative out front's gonna do?
Makes the whole film negative.
Yeah, it's just gonna stick around, isn't it? Tell you what, this will be kind of fun. Let me check your answer. Let me see what you got. And it's okay to be wrong, because you're still learning, right? It's okay to be wrong. Sorry, let me catch you up, because I have worked out. Your answer's gonna look kind of weird. Close. Close.
Oh.
close. Well, that doesn't go on the inside. Keep it on the outside. Closer. Close. How do you mess up?
Second?
Oh, no,
It's a 5, I need a 5.5.
Because
And then you have to
it's
set divide and then you have to set the even up.
This is the.
I give up.
Listen, I split the X thing in
Yeah,
half.
because since it's part of the x to the fourth times x, you take x to the
I
fourth.
should've just
down,
swapped the
x
X's
to
out.
second, x to
I'm afraid to drink
Gross.
glasses.
All right, yes.
There you go.
What? Okay, I'm having smiley faces on multiple things, okay?
Okay.
Oh,
All right. What? Oh, you need to
We
check.
just learned this stuff today, she was here today. And I care no. If I get a C, I'll fucking tell.
Okay.
If I get a what?
You get a 75.
Mine almost
And then 5.
All right.
Gonna get
So, ladies and gentlemen, first of all, I got to be careful when I write these. I really, it's really got to cover everything. So we got that. Is 25 a perfect square?
Yeah.
Most of you said yes, indeed. Now, this negative on the outside, it's where it needs to be. We're good. So we're just going to put that out front. But then x to the 5th, you can either write it how many times? 1, 2, 3, 4, 5 times. Circle your pairs. Aren't 2 x's coming out? But don't they multiply together? So it'll be x squared. And then is there something left over? Now, another way to do this, and I'm going to show you both ways until it feels like second nature. Another way to do this is to write this as what?
X to the fourth times x.
And when it's even, you just got to cut it in half, don't you?
Yes.
Elliot?
How come in the earlier problems we like put like what was left over like outside of the thing and now it's going inside?
So we never put what was left over on the outside. Only things that come outside were perfect squares. So what we had on those previous problems was they were perfect squares. There was nothing left over. There were no factors that weren't perfect squares left over. Now, I do got to give you guys a heads up. A lot of times, the book answer, they'll add a little multiplication sign in there. The reason they do that is because when some people write this, the 2 looks like it's up here. And so somebody might think that it's saying negative 5x square root x. Because the 2 would look like the index. So I just want to give you a heads up. If you check some answers, they'll add a little multiplication dot to get a little space. What's that?
Should we get in the habit of that?
No, it's not necessary. But just be aware. Well, yeah, nice work, everybody. Nice work.
Go to lunch and like.
Yeah, we'll go to lunch tonight.
Go to lunch and.
Oh, really?
I still do another smiley face once I redeem
Hey, I'll get
myself.
one now. See you guys
I
later.
redeem myself.
Have a good time. Where that hot dog?
Oh shoot, let me get the
Dog.